Hello, my name is Shinichi Hoinen. I'm very happy to have opportunity to introduce our Top SE education program to all of you. Top SE is one of the activities in NII, National Institute of Informatics. Top SE classroom locates on 19th floor of the NII building. I will explain NII very briefly between introducing Top SE. NI locates in the center of Tokyo, and it is very close to the Imperial Palace. The Imperial Palace is a normal residence of the Japanese emperor. We can reach the Imperial Palace from NII within 5 minutes walking. This figure is one of the entrances to the Imperial Palace, and the bridge was built more than 400 years ago. NI is the only academic institute of informatics in Japan. NI was established at April 2000. That is, it is still a young institute. We have about 80 professors whose research topics are very wide, such as artificial intelligence, machine learning, quantum computing, networking, cloud computing, and basic software and so on, as well as software engineering. Grace Center is one of the research centers of NII. And Grace Center is a research center for software engineering, but Grace Center has carried out not only research, but also education and practice. So TopSE has been carried out as an education activity of Grace Center. TopSE is a one-year education program for super architects who can apply advanced modeling methods and tools to real-world problems in industry. TopSE started at 2006. We have collaborated with 63 industry partners such as Hitachi Fujitsu, NTT Data, NEC, Toshiba, Canon, and so on. These industry partners send both lecturers and students. Currently, 47 lecturers come from these industry partners, and we have educated about 50 to 60 students in industry partners per year. Totally, we educated 642 graduates in these 15 years, and 1 year course fee is about $5,000. But it was free for the first 5 years because we received budget from Japanese government. And this year we have 62 students. This figure shows the attribute of the current students. By department, 75% of the students belong to the business sector. It means that 75% of the students usually relate to the development of the software system. By age, the age of 75% of students are from 24 to 34. As for the final education, the half of the students majored in information technology at the university, 7% of the students majored in humanities at the university. So I have to mention the reason why we started TopSE education program at 2006. As for the situation in academia, there were various kinds of the advanced modeling method and tools based on computer science, but there are very, very few good textbooks based on real-world problems in industry. As for the situation in industry, there is little knowledge of how to apply advanced modeling method and tools real-world problems in industries. That is, there was no practice in academia and there was no science in industries. As a result, there was a serious gap between academia and industries in the field of software engineering. So we had to transfer advanced modeling and tools to industries to improve the situation in industries. So we decided to bridge the gap between using education method. In order to transfer advanced software engineering method and tools to industries, we decided to educate super architect in industries who has modeling capability as well as knowledge of computer science. Especially modeling capability is a key ability of the software engineer who can apply various modeling methods and tools based on computer science to the real-world problems in industries. We had to explain the reason why modeling capability is a key factor for the software engineer. Software system is implemented so that it satisfies the requirement for the software system. When software system is very small, it is possible to implement software system at once. But when software system is larger, it is quite difficult to implement software system at once. There is a software process between requirement and software system. So software system is implemented according to the software process in industry. Software process consists of several models such as analysis model, basic design model, and detailed design model, and so on. There are many kinds of the software process such as waterfall process, incremental process, agile process. In any process, the role of model is very important. Model is specified from different point of view. We define the model and transform the model to the other model. Then any model should be implemented correctly, simply, and any model should be easy to be understood for any software engineer. Therefore, modeling capability is a key factor when we develop the software system. There are many kinds of the software practitioners in the software development project, such as project manager, analyst, architect, designer, and programmer. They have to treat various kinds of the models in software process. So every software practitioner should have high modeling capabilities. That is, modeling capability is a common skill of software practitioners. Modeling capability is regarded as problem-solving capability in software development. Generally, in order to get high problem-solving capabilities, we should learn many kinds of the good problem-solving method by applying them to the real problems. Fortunately, in academia, there are many good methods and tools supporting right modeling. So we decided to introduce the good models and tools in academia to our TopSE education program. By the way, we should prepare good education materials at first before starting education program. We introduce modeling method and tools in academia. Also, we introduce real-world problems in industries. By applying the modeling method and tools to real-world problems, we gathered practical tips when applying. Then we incorporated practical tips into education materials. By focusing on practice using education materials, we train the student to enhance modeling capabilities. We provided only software engineering lectures focusing modeling method until 10 years ago since the beginning, as you can see. So requirement engineering, architecture, formal specification, and model checking. This table shows some lectures focusing modeling. For example, in the lecture, formal specification, foundations, modeling tools, VDM, and V4 are adopted. Another example is verification of design models. In this lecture, modeling tools, spin SMV, LTSA are adopted. As for requirement analysis, chaos and ISTO are adopted as modeling methodologies. And as for component-based development, Iconics, Corba, components, catalysis are adopted as modeling methodologies. So, but recently, software engineers often have to discuss with many kinds of non-software engineers, such as cloud engineer, security engineer, data scientist, and also intellectual property officer. So we decided to add corresponding lectures to the original software engineering lectures, such as data science, cloud computing, security, and data-driven society and its regulation. This figure shows the overview of lectures, which consist of 9 series: architecture, formal specification, cloud test and verification, agile, requirement engineering, security, data science, and data-driven society and its regulation. And totally, we provide 46 lectures. Among them, there remain lectures focusing modeling, such as formal specification and testing and verification, and architecture and requirement engineering. So totally, there are 26 lectures are software engineering ones, and there are 20 lectures which are non-software engineering ones. Students don't need to take all of them to get TopSE certificate. Lectures are compulsory elective. So the minimum number of lectures is 10 to get TopSE certificate. We provide 2 kinds of education methods towards producing super architects. First, the students learn various software engineering issues and peripheral technologies by lectures, which consist of classroom learning and practical exercise. Second, the students apply the learned techniques to their own problems they are facing and solve them with original ideas by project-based learning. The students can get TopSE certification by taking lectures and project-based learning. Lectures are compulsory elective. The minimum number of lectures is 10 to get TopSE certification. On the other hand, project-based learning is required subject. At first, I will explain lecture style of TopSE. As for lectures, we have currently 46 lectures in the field of software engineering, data science, security, cloud computing, and personal data protection law and copyright law. We make students learn from the foundation to the up-to-date topics of software engineering and peripheral technologies, including data science. We provide the theories and principles behind each methodology and tool. Moreover, we train the students by group exercises with practical examples. That is, we provide the balanced education with theory and practice. Next, I will explain project-based learning of TopSE. Project-based learning is required subject. In project-based learning, students apply the learned techniques to their own problems by group work for 3 months with a supervisor. TopSE treats two kinds of problems based on real world. The first, problems in the lectures are given by the lecturer. Second, problems in project-based learning are their own problems. This slide shows the variety of their own problems. First, case study. How effectively can we resolve our issues by the method? Second, domain-specific support. How should we promote use of method in our target domain? Third, bridging gaps between method or tools. How should we combine the methods to constitute the development process? Fourth, method and tool development or extension. How can we overcome limitation of or difficulties in the method? So, as for summary, students should be well grounded in computer science. TopSE program supervise advanced modeling method and tools by lecture, exercise, project-based learning in order to improve modeling capability and problems discovering or solving capability, which are expected skills for super architect. So, and expected graduate of TopSE can suggest solution to any technical problems in the software project, or they can take the lead in introducing new technologies and tools, understanding their limits, and checking in practice to what extent they can apply to their own problems. So finally, our TopSE has collaborated with 63 industry partners such as Hitachi, Toshiba, Fujitsu, NEC, NTT, Canon by developing education materials based on real-world problems, sending devoted lecturers in industries, sending motivated students in industries. So thanks to industry partners, we succeeded in producing 642 graduates so far. Finally, I would like to conclude my presentation by emphasizing that we didn't carry a TopSE without the collaboration with industry partners. Thank you so much for listening.